Module 12, problem set 3. Here we're asked to come up with a Lewis diagram and to assign formal charges to all atoms in ICl2 minus 1. Let's begin by identifying how many valence electrons we have. All three are in group 7, so 3 times 7 for 21. One more to impart the minus 1 charge. We have 22 valence electrons. We'll place the iodine, the least electronegative of the elements, in the center. We'll attach those adjacent chlorines. Give everything an octet that requires an octet. Here, everything would require that octet. Everything has its required octet. In doing the accounting, I have used 20 valence electrons. I have 22. Every time this sort of case arises, I continue to add lone pairs to that central element until I use the required number. I have violated the octet rule on that central iodine, but that is okay. Iodine is below period 3 on the periodic table, so we are okay there. I would indicate that this is a molecular ion that carries a minus 1 charge. And now I can go assign formal charges. Let's do it first for this chlorine. That chlorine is in group 7, so I would have 7 minus the sum of number of electrons in electron pairs. There are 6 of those. I've got one bond line, a formal charge of 0. So a formal charge of 0 there. I recognize this chlorine is just like that chlorine in terms of electronic arrangement. It also has a formal charge of 0. Clearly this iodine must then have a formal charge of minus 1 if I'm going to impart the minus 1 charge to the structure. Let's do that accounting. It is in group 7 minus 1, 2, 3, 4, 5, 6 electrons in electron pairs. There are 2 bond lines, and indeed we get minus 1. Okay, let's move on to question number 2. All right, so in question number 2, we are asked to come up with a major and minor contributor to the resonance hybrid for N2O. All right, looking for a major, and a minor contributor to the resonance hybrid. Okay, we'll also recognize, we are told here, that nitrogen is going to be a central atom. Okay, let's figure out how many valence electrons we have to work with. Each nitrogen group 5, 2 of those for 10, 6 more for the oxygen. We have 16 valence electrons. Again, we were told that the nitrogen was going to be the central element. We'll attach the adjacent atoms. Give everything an octet that needs an octet. And we recognize here we have used too many. Coming up with that Lewis diagram, I have used 20. I had but 16 available. I'll take a lone pair away from the central element, a lone pair away from the least electronegative of the adjacent elements. I'll introduce a double bond. I'm now using 2 fewer valence electrons, but still 2 too many. So here I have used 18 valence electrons. I recognize I have a choice here as far as where I could take lone pairs of electrons off those adjacent elements. This is one way in which I could have done it. Okay, what was the other way? Well, I recognize I could have just as easily created a triple bond there. So I have 2 different resonance forms. Let's see if either of these is likely to represent the major contributor to the resonance hybrid. And we're going to do that by assessing formal charge. So let's go through and assign a formal charge. Okay, if we look at from the perspective of this oxygen, it's in group 6, so we had 6 minus the sum of 1, 2, 3, 4 plus 2, 6 minus 6, we have a 0 formal charge there. From the standpoint of that nitrogen, we're at plus 1. This is a neutral molecule. This clearly must be minus 1. If we did the accounting, indeed, we would get minus 1 there. So recognize I have some non-zero formal charges. Let's check this structure. What is the formal charge on that nitrogen? 0. Formal charge on this nitrogen, +1. Formal charge on this oxygen, -1. And if I were now to try to decide which of these is more likely to be my major contributor to the resonance hybrid, I would select this because I have the negative formal charge on the more electronegative of the elements.